those who not using a student email will not be able to join the class. Okay, so please use your student email to sign in. Okay. Okay, so for today, we'll continue with higher order partial derivative. Okay, so if you look at the example over here, okay, so we will be having, can see or not? Mm, okay, so here, okay, so higher order partial derivative. Okay, sorry, because this is my first time to online class with this to write something on the screen. I mean formulas. Okay, so yeah, so if I'm too fast, then please let me know. Okay, so this is the multi-variable functions that we have learned yesterday, the f, okay, bracket with x and y. Okay, so you can see here in the equation, you have x, y, okay, all these x, y variable. Okay, so if you want to differentiate it with respect to x, so what you will get? Okay, so let's say for this one, x cube. Okay, for this x cube, okay, if you differentiate, okay, with respect to x, you will get 3x squared, correct or not?
Yes.
Okay, so followed by the second terms. Okay, the second terms you will look at the x squared. So when you look at the x squared, so when you differentiate this, the x squared will become 2x, right? So 2 multiplied by 3 here will become, so the minus sign you can copy lah. You can just copy. Then you will get 6x y to the power of 4. Okay, so this will be remain. Okay, and then plus, okay, e to the power of xy. Okay, at the end, because of the x here, okay, you'll be able to get y times e to the power of xy. Okay, so make sure you are filling in to your slides. Okay. Okay, so after the first derivative, okay, you can do the second derivative here. So you can see here there is two arrows here. Okay, so the first one, okay, the first one you can see delta square f over delta x square. Okay, so this one is to differentiate these again, okay, with respect to x. Okay, with respect to x. Okay, so you can see here. Okay, sorry, I'll change to red color. So you can see here. Okay, so differentiate this with respect to x. Okay, so we can do it together. So 3x squared, okay, you will get 6x. Okay, 2 multiplied by 3, okay, and 2 minus 1 become x. Okay, then followed by this term, negative 6xy to the power of 4, you will be able to get negative 6y to the power of 4. Okay, because the x will be cancelled off. Okay, and finally, this term, okay, because you still differentiate with respect to x. Okay, so your answer will be y square e to the power of xy. Okay, okay, so anyone can answer me on this second derivative if we differentiate this with respect to dy. Okay, so what is your first term? Okay, so I'll give you 1 minute to do this. So this one we apply with the chain rule that we have learned before. Okay, or you can see the clue here, the product rule. Okay, you can see the product rule. You can use the product rule. to solve it. Okay, anyone with the answer?
Negative 24xy cube
Anyone
plus,
speaking?
negative 24xy cube,
Again.
negative 24xy cube,
Yeah, and then followed by,
followed by plus xy exponent or power of xy, xy exy,
okay, plus
plus exy.
EXY. Yes. Okay. Okay, guys, you can use this product rule. Okay, so I can show one time, okay, about how we get from this to here. Okay, so your function, okay, you want to derive this. Okay, so this one we call it f lah. Okay, with respect to y. Okay, so you want to do this xy. Okay, so you can let u equals to y, v equals to exy. Okay, or exponent exy. Okay, so with reference to this product rule, okay, it will be u differentiate u, okay, times v plus differentiate v times u. Okay, so this is the general terms. So how you do it? The first one, you differentiate the u. Okay, when you differentiate the u is this y, right? So it become 1, and the v you just copy exponent or e to the power of xy. Okay, plus then you what? You differentiate the v. Okay, when you differentiate the v, you get x e xy. Okay, and then you copy the u. Okay, u is the y here. Okay, so if you put them together, you will get exy plus xy e to the power of xy. Okay. Okay, so this term, okay, we put here. Okay, so this is the second order derivative. Okay, you need to check. Okay, you want to differentiate it with respect to x or y. Okay. Okay, so now I'll give you 2 minutes to complete this. Okay, same, you refer to the same equation here. Okay, refer to this same equation. Okay, you do the first derivative and then you do the second derivative with respect to dx or dy. Okay. Okay. So first of all, when you differentiate the equation with respect to y, okay, so this time you with respect to y, you will get negative 12x squared y cubed, okay, plus x exy. Okay. Okay. So you use the same method of the product rule, okay, to do the second derivative. You will be able to get negative 24xy cube plus exy plus xy exy. Okay, so please be honest to yourself. Okay, if you cannot follow, okay, you can just copy the answer first. But when you go back, you can try to solve the questions. See whether you can get the correct answer. Okay. So finally the second one, okay, with respect to y, you will be able to get negative 36 x squared y squared plus x squared exy. Okay. Okay, so followed by then you can see this, okay, the notes here. The second order derivative is the derivative of the first derivative of the given functions. Okay, so this is the given function, okay, first derivative and second derivative. Okay, second derivative, you depends on which variable, okay, whether you want to derive for x or y. Okay. Okay, so at the bottom, you can see this, okay? So this is how normally we write it, okay? These three, okay, are equivalent, okay? So if you see this like this, fxx, okay, here, this one can see the fxx here, okay? So for this one, okay, it is actually the first order you derive with respect to x, and second order derive with respect to x. Okay, so you can see this is the first of the order. Okay, so delta f, okay, with derivative, okay, with respect to x. Okay, so the second order also with respect to x here. Okay, so or it will be written in this way. Okay, delta square f over delta x square. Okay, or it can be written like this. Okay, fxx. Okay, so for the second one, okay, if you see this, eventually the first derivative is y. Okay, the second derivative is x. Okay, y and x. Okay, so here is the notes. Okay, this is with respect to. Okay, with respect to. Okay, so at the right side here, okay, first derivative is x, second derivative with y. Okay, so the final one, first derivative is y, second derivative is y. Okay, understand? So these three form can be written. Okay, it's all equivalent. All right. Okay. Okay, followed by next questions. Okay, so for this question, same, you have multi-variable x and y. Okay, so now you look at this question, fx, okay, okay, derivative with respect to x. Okay, so if you look at here, with respect to x, so this is the term that you need to look for, right? X squared. Okay, so for the x squared, when you derive, okay, it will become 2x. Okay, so the whole thing cos, okay, x squared plus y squared. Okay, it will become sine x squared plus y squared. Okay. Okay, so this is the first term and the second terms. Okay, so it's actually a multiplication lah. So the final answer will be 2x x squared plus y squared. Okay. Okay, then you can see from here, the second derivative, you can, okay, there are two. Okay, so the first one, they derive with respect to y. Okay, the second one, they derive with respect to x. Okay, so the first one, okay, we just follow from here. Okay, we just continue from here. Okay, so derive with respect to x, right? So, oh, sorry, derive with respect to y. Okay, the first one with respect to y. So, with respect to y. Okay, so 2x is actually the constant lah. So, we just copy the 2x. Okay, so what we are doing here will be derive with this part. Okay, we derive this part with respect to y. Okay, so you will get the 2x, you just copy lah. Okay, so the sign h, okay, you will get cos h cos xy plus, okay, x squared plus y squared, sorry, and multiply by 2y. Okay, so this term multiply by 2y. So finally, you can just rearrange it. So 2, this one, and this one multiply together, you will get 4xy cos x squared plus y squared. Okay,
A bit confusing. Eh?
which part? The
Uh,
second one or the third one?
the second one.
Second line. Second line. Okay, so we go back to the second line. Okay, so for this one, the second derivative, we derive with respect to y, correct or not? Okay,
Yeah.
when we derive with respect to y, so the 2x, we just treat it as a constant lah. So we just copy it. Okay, so this is outside your derivation. Okay, so within this derivation, what is the terms that you want to derive? Sine h, okay, bracket x squared plus y squared. So now you derive with respect to y. Okay, so this one y square, if you derive it, it will become what? 2y, correct or not? This is the first term. Okay, just like your the example here. Okay, so the 2y, and then with remaining this sign, okay, it will become cos. Got it?
Yeah. The part I don't understand is why the 2x wasn't treated like a constant becoming 1. Instead, it just came down there
Which
unchanged.
one? This one?
The 2x part,
The 2x?
the 2x, it just wasn't changed like I thought it would
Because,
be.
all right, so the one, if you think that it's become a 1, that one is 2x plus something. But this one is the whole. This is the whole term. This is a multiply in. Yeah, so this is the 2x is just, you just factorize it out.
Oh, okay.
All right. Okay, so your answer will be 4xy cos x squared plus y squared. Okay. Okay, so followed by this one. Okay, you use back the same first order here. Okay, the same first order. Okay, so now you're doing fxx. Okay, you derive it again with respect to x. Okay, so with respect to x, so the 2 is a constant here, you can just bring it out, and then you deriving the remaining part, which is x sine x squared plus y squared. Okay, so the 2 you just copy. Okay, so sine so this one you can use the product rule. Okay, you can use the product rule, and you'll be getting sign here. X squared plus y squared. Okay, so plus 2x squared cos x squared plus y squared. Okay. Okay, so this is the answer for the fxx. Okay. Okay. So over here, this is referring, you can apply the product rule. Okay. Okay, so you can use the same method and complete this part. Okay, guys. Okay, you want me to give the answer now or you want to do it and I'll upload the answer later? Okay, up to you guys. You want to answer now or I will just upload it later to the Google Classroom for this section? Upload the answer, all right? So, okay, you guys try to do it. So I will upload it later for this part, okay? Okay, so it's just the same, but this time you do it with respect to y first. Okay, and then for the second order with respect to y again, and the second order with respect to x. Okay. Okay, next. Okay, so for the higher order partial derivative, the above definitions of partial derivative can be extended to function of more than two variables. Okay, so just now the example, you only have two variables, x and y, right? It can be more than two variables. Okay, it can be more than two variables. Okay, then for your derivative, it is depends. Okay, it depends on you derive with respect to which term. Okay, you can see with the first one fx, okay, derive with respect to x, the second one with respect to y, the third one with respect to z. Okay, so for the first one, if you derive with respect to x, you will get the first term with respect to x. Okay, y is the constant.